Alright everybody, welcome to the stream. Let's see how many people are actually in here. I got 2 people in here. I think one of them's me, but that's fine. So the first thing I'll do is I'll show you the CAD design of the Racer 4 LA, where it is right now. All of the stuff that's not inside this finished folder is stuff that still needs to be tweaked. Other than these spacers, they can go unfinished. But the flight controller is mostly done, and the flight controller I'll get into in a second. I have to change out this connector back here to add in the 3D model for the boot button, and that's pretty much it. Everything else is modeled up and spec'd out, and then I have to complete the documentation for it just like everything else. But other than that, the bottom cover is designed up, it's modeled, and also I have a plan for how that's going to be created. Let's see. The first question I have was by Aeroflyer, and he asked, have I chosen an FC yet, and if so, is it F4 or F7? So it's a complicated thing, but the gist of it is, yes, there's a flight controller right now. It's custom built for the frame based on the footprint that DRL has, and I don't think it's 30 by 30. I think it's slightly bigger than that. So it is, yeah, 35 by so it's 35 by 43 pretty much. It's a little awkward of a design. That's not to say though that this is the only flight controller that'll work with this system. When the power distribution board, this green board down here, when that's finished, it'll have ports on it so that you can connect any flight controller to it, as well as there will be a mount included with the kit that'll allow you to replace all of these spacers and this flight controller with a flat printed board so that you can attach a 20 by 20 or 30 by 30 stack to it, and that'll enable anybody to use their fancy gyros or their fancy systems, anything like that. But this one will be the official Racer 4 LA board. What it has on it right now is it has a USB Type-C connector on it, so you can not fuss with which way you're plugging in your quad at the heat of the races, and also just make this connection a little stronger. I've never had a micro USB break off, but I have had them wear out, and you sort of have to wiggle them to get them to work, so hopefully that fixes this issue. The other thing is it's got some pretty hefty filters on it for the on-screen display, and so hopefully video will be going out pretty clean. This whole flight controller is also powered via 5 volts coming from the power distribution board, and that'll hopefully save any electronics that go through it. Another feature of the flight controller is it has a built-in barometer. It's actually on the bottom of the board, and that'll allow you to see altitude if you care about that, but it's just a little feature that I had an open port for it. I added in. It doesn't take a UART or anything as far as I know, so it doesn't limit you in any regard. And you can always turn it off if you don't want to use the cycle times. Some of the outputs on this board is, as you can see, it has 2 plugs, and these are, I believe, 4 pin on each side, so there's a total of 16 connectors, and most of them are being used. There are a couple of them going to the flight control, the LED controller. Sky FPV, I see your message. So, Sky FPV says, have you developed an FC before? I'm blown away by how quick you came up with all of this. So I myself have not designed an FC before, but I have been basically the flight controller that's here is a mash between the Pixhawk Racer FC, the the Omnibus F4 Pro flight controller, and the Drone Mesh's OpenFC controller. So it's a combination of all those schematic files that I've gone through and rewired and put together. Right now it's running an F4 processor, but I'm working with Drone Mesh to hopefully bring his F7 variant to this board, so then I'll have an F7 and upgraded gyro, so everything will be cool there. But with some of the connections going to the LED controller, you have the TX and RX pads, which is using a UART, so you can control all of the LEDs from your flight controller. There's currently 422, I think. There's 102 per side of the arm on the top, so each of these LED panels on the top are 51 LEDs. The bottom of the arms have 120 LEDs, and the top span I haven't completely modeled up yet, but that'll probably bring it closer to the 800 or 900 that DRL poses on their website. Then again, to the front, you'll have a connector on the front of this little green board for the power distribution board, and that'll be to connect up your camera. It'll fit any micro camera in the slot. And there'll also be, which I'm working on right now, a little servo hidden in this section here, and there's a pin out on the flight controller to allow you to control the tilt of your camera via your flight controller with one of your transmitter pins and transmitter channels. So I think that'll be a little nice feature. You can remove it if you want to save weight, but the drone is already pretty hefty as it is. Let's see. The motors themselves are 2510s and 3500 kV. They're made by Brother Hobby, so no custom design there. DRL has two different KVs listed. One's on their website, and then one if you go into their simulator and you fly their Racer 4, they show a different KV. Yeah, the power distribution board will also be able to run, in the future it'll be able to run if you wanted to put a different LED controller. I know there's a couple of them out there. You can add that in. It's going to have built-in regulation, and also I'm working on having it have a built-in soft resetting fuse. So if you plug in a battery and it overcurrents the drone, the fuse on the power distribution board will flip so you don't fry any of your electronics, hopefully. That's still work in progress. The flight controller is going to have an output for both Spectrum and FrSky, so you can plug in whatever you want to it. As well as it's going to have an output for any video transmitter you have, including smart audio. It has smart audio functions on it. All of these pins here on the ESCs, these are 2-in-1 ESCs, one per side. They're plug and play. The 4 in the middle are your actual LED and motor pins, and then the outside are your actual power pins. On the DRL quad, this has been told to me by someone who knows someone that has a DRL quad. I don't remember his name, but he said that the 20-pin connector on the actual DRL4 is for all of the LED connections and a number of other connections that I don't know what they go to. And then there's 2 pads underneath of the whole thing that actually connect up your power, so you're actually having to solder to the board. With this, I've done away with that and done these connectors. These connectors should be able to handle 30 amps through them, which each ESC is 30 amps, so a total of 60 amps. And we'll see how that goes. Everything on this drone is pretty much plug and play. There's no solder points on it other than these top LED boards. That's actually a ESC with a LED pin on the top of it, LED panel on the top of it, and then you have your 3 motor wires on the bottom that feed through this little cutout, and the cutout is one for support to support the ESC off the arm, as well as protect it from any kind of prop strikes that will hit your motor. And there's a little printed part that goes under the ESC so that there's no shorting of grounds or anything like that. Let me remove the bottom cover, and I'll remove the camera now. Why not? So underneath you have this, these are the LED boards underneath. They run in to the center of the frame, which then run up through the power distribution board. Find that. Power distribution board. And they connect in via these 4-pin headers, just power, ground, and then your data in and data out. for your LEDs. And it's all snapped together and all held together with screws. The screws that go into the bottom cover and then screw into the top cover secure the underarm LED panel, the frame board, which is 5mm carbon, the spacer plate, the 2-in-1 ESCs, and the LED panel. And the ESCs were designed off of Drone Mesh's Open ESC project with some tweaks to it to make it handle the 5S current. All the components are rated for 50 volts and I think 120 amps. So they shouldn't have any kind of problem with blowing up or anything like that. The FETs might get a little hot because there's not really a lot of airflow through here, but I might be able to make up a small heatsink plate that goes in there and at least helps radiate some of the heat. There's future plans for connections on the flight controller for a custom-built receiver and video transmitter, sort of like how DRL has their advanced video package or advanced streamer package. Advanced radio package, I think that's what it's called. And then there's also plans to add in connectors for an AI racing package, which replaces your camera and GoPro in the front for some sensors and goes into the AI racing board and converts it and spoofs it as a S-bus signal and sends it into the drone to control everything. Because there's not enough UARTs or pins on the F4 to support another controller it's able to talk to. So right now the flight controller is talking directly with the barometer and the gyro and the OSD chip. I can isolate the flight controller. So with the flight controller, we have the two sets of connector pins on the bottom. This is the gyro. I haven't found a 3D model for it yet. This is a regulator, I believe. You have the OSD chip here, and then the boot button over here. So this is a 3-volt regulator that will support the chips and any of the Spectrum receivers, anything like that. USB Type-C connector. You have a micro USB black box logger, and that is the push-in lock kind, so you don't have to fiddle with unlocking it while it's in the stack. What else is on here? Barometer. Actually, I don't see the barometer on here, but I know it's in the schematic. That might be the barometer there, actually. Then you have two status LEDs here, and I'm thinking about actually moving these and putting them to a pin that I have open so that all the status LEDs for all of the different components are visible in one little line with lights on them. So if something's not working, you can just glance at a status section of the board and it'll tell you what's wrong, as well as having telemetry come back from the ESCs and give you a status LED if they're working correctly, if they're not working correctly. And another question that I didn't really get an answer from on the Facebook group is, what would you rather have? Would you rather have to connect into the LED controller, which currently the connector is being blocked by the camera mount, but I have space on these side panels so I can move that connector over there so that's easier access to it. So you'd have to plug into this controller board to change the LEDs. The other option with that is if you do plug in directly to this, I don't need a UART being sent from the flight controller over to the LED controller. So I can use that UART to enable wireless BL Heli configuration with a Wi-Fi chip. So make the whole thing wireless. But if that's not a big concern or people don't really care about that and they want to adjust their LEDs without having to plug into it, then we won't have an open UART, at least on the F4, to do any of that kind of stuff. All these components are pretty cheap to make right now. I'm looking for my booklet on all of the stuff that I did. There it is. So right now what I have modeled up is the underarm LEDs are a little over $17 a piece, so that's $34, a little over $34, about $35 actually for the whole thing. Could you drop the Baro to get Bluetooth and LED control? I'll definitely look into that. How the controller talks to it is 4 pins, but I can look into seeing if there's an open UART on that flight controller. That would actually be nice, because when I put in the barometer and it's like, no one's really going to use this, or it's really needed. So yeah, I'll definitely look into that. Thanks, SkyFPV. Yeah, so the main body spacer, which is the 3D printed part, it's actually this piece here. That's going to be a printed part. You can either print it yourself, or you can get it purchased, and it's $5.99 if you get it purchased. The Esc Spacers, which are the spacers that prevent grounding on the ESCs and prop them up off the arm. Again, you can print those yourself. I think they take about 20 minutes to print, or maybe even less than that. I printed them all out on a CR10, and so those are $4.99 to make. There's 4 of them though, so that's about $20. The 2-in-1 ESCs are $24 each, and there's 2 of them, so that'll run you about $48. The LED panels are about $6.50, and again, there's 4 of them, so that'll be about $25 for that. The LED controller is about $12.50. There's only 1 of them, so that's fine. And then the motors are directly from Brother Hobby, and they're $25 each right now, so that's about $100 for you. The flight controller should be about the same price as the 2-in-1 ESC. It's about the same component part list. The amount of components that go into the FC is about the components that go into the ESCs. And I'm hoping to get these produced as kits, so you can just order everything and you can build it yourself, or you can get them made by me, or I'll have them professionally made and get everything out that way. Currently, I have all of the documentation written up for the actual components. I have all the pinouts and schematics, and where all the components are placed on the board, both front and back. So if anyone needs to rebuild something or wants to tweak it, they can do that. There's bill of materials lists and images that people can go off from. So it's a fully documented kit. Hopefully there's a lot to go off of there. Let's see. What else can I talk about? SkyFPV, you got any other questions? And I know some people have asked if there's a possibility of having being able to add your own ESCs in, and it's been on my mind for a little bit. Is there room for future DJI HD? Yes, there is. There is room for it. If I add in everything, I can show you how much room we have right now. Go up to the rear fins and the back sled. Where is it? Oh, there it is. Okay. So right now this is the cross section of the Racer 4. This is the LED controller. This is the flight controller, and this is the power distribution board running along the bottom. Normally the LED panel on the top would run really close to this top section. But I don't have one modeled up, so it's not there yet. I have a rough mock-up of what it actually looks like. So this is the cleaned up version of the LED panel, and then there's LED panels all across the top. These little side parts are stickers so that you can stick it to the top cover. Just haven't modeled up where the LEDs go because this is such a complex geometry. So getting the DJI HD to fit, it would probably be mounted in here. The flight controller can be squished down with a ribbon cable because it's only using 5 volts, so there's not much going to it. So that'll be something I'm going to look into doing so that we can move this down, reduce the height of these spacers, and then also seeing if I can remove these connectors. There'll be a wire connector in between, but it'll make it whole thing smaller, or even flipping the connectors over so that they're under the board, so you have even more room to mount the thing. I think if you decase the DJI HD, it'll go under the whole thing. It'll go in this little space here. But yeah, I've definitely been thinking about the DJI HD because I know that's how people are starting to run toward. Because the FPV analog signal is just not fast enough for us to see what the hell's going on with some of those really fast racers. Thank you, Aeroflyer. That's a good question. I mean, and again, with regards to the DJI HD controller, if you want to, you can pull out the GoPro section. I can add in a mount so that the DJI HD unit actually goes in the space where the GoPro would go. Sort of like you would have like the RunCam split where it's a separate board, and then the camera will just run into the camera section. The battery, pull out the battery. Okay, so I haven't put the battery in the thing, I don't think. But could just make a GoPro session 3D print. Yes, exactly. FPV. Yeah, so here's the battery up here. It's a 5S battery. It's 2200 milliamp, I believe, on the DRL website, and because of the size of the Racer 4, I think it's not as big of a problem that we had on the Racer 3 with fitting the battery in it. But I'm looking into that. Also looking into building my own batteries as test platforms. But I've worked with Pulse before, and they've been willing to bring their those batteries back to it, back to market if a lot of people are interested in it. I think for the Racer 3, I got them to agree to make the Racer 3 battery if I could get an order of 200. And I mean, the Racer 3 is completely done. It's designed. It's ready to go, except for the battery. But that's a different project. The top fins are a separate section from the actual top cover. So this will probably be printed, and this will be injection molded, or ram casted, as I like to call it. And I don't really see the point of this little hole in the top cover. There's nothing really there, at least on the on my version. They might, I don't remember what they have here. They might have like dip switches or something there, or maybe status LEDs. I don't really know, because there's a hole in the LED panel too, where when I first designed it up. For these little side holes, you have the access to the micro USB, which I'll have to flip it onto the bottom side so that you can actually access it, because I think I made the standoffs taller, and that messed everything up. But on the other side you have access to the micro SD port, and might have to realign that a little bit. In the back here you have the section for the battery lead to come out, and there will probably be a 3D printed grommet or a casted grommet here to protect that from wiggling around, and also make it a little bit more watertight. The two antennas up here can either be both 5.8 transmitters for like a diversity type transmitter, or one can be 5.8, one can be 2.4, and they just go into your equipment. And then for your antennas, for your, if it's both 5.8, then you can have antennas on the inside for your 2.4 signal, like in the fins, which I originally thought their purpose was they had actually like flat panel antennas, sort of like the ProSight had flat antennas, sort of like what that would be like. But I think what they're using this for is just for stabilizing it in flight, like a rudder, to help it turn better. The front has space for a little sheet of like acrylic or something to go in the front. I was talking to a guy that owned a Racer 3, and he says no one really ever used this front cover. It makes the video look a little weird, and the lens actually presses up against the acrylic sheet, so there's no real point in having it. It just makes everything look kind of wonky. Might try some stuff out with getting something in there to protect it from, like, if you fly through a water stream or something. And the both the back skid and the fins both lock into place with screws. If you watch the video that Rotor Riot made on the Racer 4, they talked to one of the DRL engineers, and he said it's held together with 8 screws. It's held together with a little more than 8 screws. I mean, yeah, 8 screws going around the canopy, and that mounts most of everything to it. But unless they're doing something funky with engineering that the screws are built into the plates, all 6 of these sections have screws in them. I think they're countersunk screws, so that they don't square up the battery, but they don't have to be, since the LED panels hang down underneath the plate. Yeah, and there's the advanced radio package, as they call it, sits on top of everything to go in there. So if I can work with DJI to get that schematic and actually just make a custom version of the whole thing, that would be great, but I don't see that happening. The LED controller was actually based on the Fade Candy LED controller, which originally has 8 channels for 8 64x64 or 8x8, sorry, LED panels, which had 64 LEDs in them, and it was designed to run 8 of them with a method called dithering, which is if you want an LED color that isn't just red, green, blue, and you wanted to add in, like, I don't know, a purple channel or something, or more commonly you wanted to add in a white channel, you would have the LEDs strobe the one color that you wanted, and then the other channel that the LED chip is missing, so that to your eye it would look like a different color. That takes a lot of processing time and cuts down the amount of LEDs that you can run. So my plan is to disable that and to be able to run all of these LEDs, because it's only using one channel, but there's no other channels available, so all the processing speed will be going toward running all those LEDs. And the LEDs are individually powered and individually addressable, so that if one LED goes out, the whole strip doesn't go out, like sort of like a Christmas tree. So we want to ask the question of, is there anything that's not on the Racer 4 that you want to see on the Racer 4? I'll definitely look into getting rid of the barometer for adding wireless configuration. I think that would just make things nice, and it would work on anything that can connect to Wi-Fi, so like your phone or computer or anything like that. The ESCs are designed to run BL Heli S. I'm going to try to see if I can, in a future version, get them to BL Heli 32. But I think they can run D-Shot, some of the upper D-Shot levels, with BL Heli S, and I believe they can run bidirectional, so you can use turtle mode, but I don't think the drone is so flat on the top that I don't think you'd really be able to unless you land and you use the back two motors to flip yourself over, because the fins are sort of like your turtle fins. Maybe that's what they were designed for. See any more of the comments in here? Let's see. Here's a Ecad layout of the 2-in-1 ESCs. If I show the polygons, you can see, so red is, they're not individually signaled. Red is top of the board, blue is bottom of the board. But if you zoom in here, so ground is on this side, the top section of the view that we're looking at. And they're through holes, so they're both connected at this top and bottom plane. They run underneath of some of these traces, and then there's a couple traces in here that bring it back to the top, so that you can run your line all the way down, and you have these thick traces to be able to support the thick current. Sky FPV. Have you considered using a wiring harness to connect the LEDs to the main board instead of a rigid plug? You'll notice the LEDs going out during episodes, and I believe that's caused from the arms flexing and breaking the LED connections. I haven't thought about that. That's a good point. I've never had it happen, but then again, I've never had LEDs this big, like an LED board this big. Yeah, I don't know if that would be that. So I don't know if that's a huge issue because of how much. So the how much is on the arms to keep it from flexing. So the carbon fiber is 5mm 3K twill, is what it's spec'd out to be. Then on the bottom of the board you have it's 1.6 millimeters thickness of a PCB, and that's got the LEDs on it. Then and that's stacked directly flat to the board. And then you have on top of the arms you have the LED spacer, and then you have the ESC sections, which is 1.6 millimeter, and then you have another 1.6 millimeter on top of that, which is your top LEDs. So if you had a wiring harness, then it'd fix the problem that if they flex they might break, but then you'd have an extra set you'd have extra height and extra weight and stuff like that, and it wouldn't like snap down to everything. And although this is just held in with 4 solder connections, there'll be a line of like adhesive or something underneath the LED panel so that you can pull it up if you need to, but it's still stuck down so it's not vibrating on this end. It's a good point, but in the testing and prototype phase, there's going to be a total of, I think, 3 or 4 of these prototypes made before they actually go into production. The first one is just the bench testing rig to test all the components and everything like that. The second one is going to be a burnout test, which is it's plugged into a power supply and the motors are run until something fails. The third one, I think, is going to be the way it would be. Second one would be the endurance test. The third one would be the burnout test, whereas you'd fly the drone would be connected to a power supply, and the drone would be stepped up the different LiPo stages. So like it would start at 4S, and then it would go to 5S, and then it would go to 6S, and then go 7S and 8S, and to see when the drone fails and where it fails. And the reason for that is to see if something is to fail for some reason, where would it fail? Not to say that if it supports an 8S LiPo to go plug an 8S LiPo into it. That's not what I'm saying. But the point of it is, if something fails, where is it going to fail? And then the fourth one is going to be a sacrifice tool that gets flown full speed into something like a wall or something like that, to see what breaks. And I think it's going to be the canopy will probably break, but to see what damage can be done to the thing before it's not flyable. And all that data will be released in terms of in form of like a YouTube video or like another Twitch stream or something like that. EG Pew Pew saying nice, thank you. EG Pew Pew, hey Michael. Hey, how's it going? Hey Anthony, how's it going? I'm glad you could stop in for a little bit. I know you texted me saying you were at work, so if you can't catch most of it, I'll put it up on YouTube so you can see it after you work. So it'll be good. And let's see, what else can I show? Why is the LED board USB plug right behind the FPV camera? Yeah, so that's it's not where its final resting place is planned to be. That's just the only space on the board that I had the ability to put it right there. Its plan is going to be on the back facing inward toward the flight controller or on one of the sides. But because of the circuit design, I just put it in the front just to make things easier. But that's not the final resting place for it, because I know that would be annoying having to pull out the camera assembly just to get to the LED board. But also, hopefully, you won't need to, because the flight controller will talk to the LED controller, so everything will just be done with your sticks, as well as your like Betaflight OSD or Smart Audio, everything like that. And I mentioned earlier how the camera is going to have a small servo to control servo tilt, or control your camera tilt. That's not just going to be able to be used with just the flight controller that I've made. It's just using an aux pin, so like one of your like servo pins that you can use, and there's going to be a plug-in for that if you wanted to use a 20x20 stack or a 30x30 stack. So you can just plug in one of your, like if your board has a motor 5 or motor 6 pin, you can do that. And right now it actually has camera control built in, so you can control your camera settings through the on-screen display. That's using motor 6 because it needs a built-in timer. I'm curious why you are going with custom electronics instead of using predominantly off-the-shelf products, e.g. Example, flight controller, ESC. So the reason behind that is because the tolerances and where everything goes. The future design is going to have the ability to add in whatever you want. Like it's going to have the ESCs are going to be something you can add in your own ESCs to. It'll basically just be a frame kit. The amount of LEDs you need on the kit are too many for Betaflight to handle in terms of individually addressable. There's going to be a version that they act as one channel, so that you can control it off of your flight controller. They won't need a dedicated LED controller. The flight controller is already there's already plans for you being able to add in your own flight controller and still support the camera control, the camera servo tilt, everything like that. And the ESCs, the space under this arm. I'll give you a so if I go from the bottom of the ESC flat panel board and the top of the arm, it's about 4.5 millimeters, 4.6 millimeters. I can improve that by saying that you don't need the actual ESC board. If you wanted to add your own ESC board, the ESC board right now would just turn into a race wire board with ability to connect to your LEDs. But if that's not, like, if you don't want that, you just want to run your own stuff, there will be a 3D printed part that runs down the arm that lifts up the LED panels. You'll have a pin on the back of the you have a connector on the back of the LED panels that you can plug into and run into that, run into whatever you want. So there's definitely a thought of doing that in the future. And I don't remember who said it in the group chat, but it was a good idea of having an official, sort of quote unquote official version of everything, and then adding in the ability for people to put in their own ESCs, their own flight controllers, their own whatever they want to put into the board, they can. But I guess this was a try at what DRL has of their own proprietary stuff. because they had some good design things, like the plug and play system. That's great. The plug and play of the ESCs and all the, like, how everything just sort of snaps together with screws. Great idea. Some of the things that I added personally, that I don't think are on, is the camera servo tilt, camera control, and the USB-C connectors. I think those are the things that I added myself that weren't with this originally. The LED controller is Python. I think you can use Python, C+, or Arduino with it. It connects via any of those protocols, so if you wanted to hook up to it and change something, you can do that. Anyone else want to see anything or have any other questions? I will probably run. It's been good so far, so I'll probably run for another 30 minutes or so. See how things go. And then it'll be the end of the first vlog update. I know some people in the Facebook chat have, over this lifespan of this project, have asked about like surprised that I'm not doing a Kickstarter or like Patreon or anything like that, and it's like I thought about it, but it's free to design this stuff. This is using free software. Eagle and Fusion 360 are free to students. And so that's what I've been doing, signing everything up. The schematics are free online. You just have to look for them, and then you have to use your designing brain to make it into what you want. If you haven't seen the YouTube video on how I built the LED controller, that's sort of what goes into it. You find a schematic, and then you bring in the board outline from CAD. You design everything up, modify it to what you want, and then you push it back to CAD so that you get this 3D model. I know in the Facebook chat, I don't really know how to pronounce it. I think it's Quantic Blender. He also pushed out some cool stuff with having a frame design as well, and great. I'm glad he was able to do it as well. In terms of designing it from what's available online, it's not tremendously hard. It just takes a lot of time to get to this step in the project. I've probably put about 80 hours worth of time into it, and maybe about 20 or 30 of those hours are learning it. Sky FPV, are you worried that once you start selling a DRL, we'll send you a cease and desist? So I've talked with, when I was going on the Racer 3 project, Ryan Gurry reached out to me, and we talked a little while, and the end of that conversation was you can't sell it because we're coming out with a kit, a street kit for people to buy. That was my interpretation of that whole thing, which ended up being the Racer 4 street. And they said that like, you're not allowed to sell it, and then we're going to send you a Racer 3 in return. So sort of like a deal, like I don't sell it, you give me Racer 3. That's how I took it. That never happened, and he says like, oh, we're still waiting for the kits and stuff like that. And then when the Racer 4 Street came on to Kickstarter, just never got one. And then toward the end of the Racer 3 project, Nicholas Horwatchke, I'm messing that up, but the CEO of DRL messaged me, and the extent of that was like, glad to see you're a fan in it, and he didn't shoot it down. He said that he, like, let's talk before you sell anything. I messaged him back saying I'd be interested in talking, and basically he's just left me on red ever since then. The Racer 4 coming out, there's been a couple people that have commented on the stuff. The manager of digital marketing, I think, Amy, I think she originally posted on the Racer 3 saying to be careful of it because it might be a scam or everything like that. Well, because we don't know who the author is. Well, I'm the author. And then I think she posted it again on the Racer 4 saying it's the DRL Chaser 4 or something like that. I don't remember. I took that as a lighthearted joke. But I haven't got any. I've reached out to DRL on both the Racer 3 and the Racer 4. I don't get any messages back from them. Yeah, it helps keep fingers crossed. The thing that I'm doing with this project is I'll sell the kit, right, for people that don't want to do all this stuff on their own. If they send me a cease and desist, fine, I'll stop selling it, but all of the files, documentation, and ability to do this stuff yourself will get released in the form of an open source project, so that people can go out and do their own thing. Now, I'm 100% willing to work with DRL. I've tried for 3 years now, but for whatever reason, it's just not going through. And the other thing, my view on is the Racer 4 Street didn't go out anywhere, so there's nothing on the market to contest it. And all of this stuff is, yes, they made it, but it's not confirmed to be theirs because I don't have their schematics and their designs. So if it go, like, intellectual property wise, is it the same system? But a little tidbit on that, I guess. Not down the rabbit hole. The DRL. Yeah, that's why it's called the Racer 4 LA. Because I'm not really that clever when it comes to naming things. Like the Racer 3 before it landed on Racer 3 LA was called the RIP. And RIP came from the fact that it was basically a rip of DRL's Racer 3. There wasn't any electronics in it, so it was just look at the photos, look at the videos, and scale everything and design everything up in CAD. And I know there's other ways of doing it, more shady methods of getting those files, but it's not that hard once you do it for a little while. It's a learning curve. Everything has a learning curve to it. And I mean, you can use files for reference, but as long as you're not directly pulling anything, it's fine. In my eyes, anyway. But I mean, in the Facebook, I don't think I've gotten any bad messages from either project. So it's been great. And when I said earlier about Amy's comment, I don't think she meant it as derogatory or any kind of like, oh, don't do this, it's a scam. I think she's just trying to put out her comment that it's the internet. At the time, I wasn't super known around the Facebook group chat. So it's just sort of like a cautionary text. I didn't take that personally. So Amy, if you're watching this, I'm not upset, and I'm not trying to diss you or anything like that. I talked with Cricket FPV. I knew him before he joined Rotor Riot. I talked to him a couple times, and I talked to him again after he flew the Racer 4, and we talked about how I had one being designed up, and we talked a little bit about it, but not much really came from that. Maybe he's pretty busy with Rotor Riot now, so. I'm also planning on streaming all the build process, like all the build stuff for this thing. So those will probably be like an hour or two streams per build, because everything is hand built right now. I have quotes back from manufacturers on actually building everything, and to get them to the price that it would cost to build yourself, you have to buy them in bulk of at least 10 parts per piece. So the LED controller, the flight controller, those are easy because there's only one of them. So if you buy them in 10, you can make 10 drones. Well, if you buy 10 ESCs, you can only build 5 drones. And then if you buy 10 LED panels, you can only build 2 drones, and then you have some extras. So in that regard, if I was to price it out so that there would be 10 drones built, which currently there's 8 people I think that voted for yes on the Racer 4, like that they'd be interested in getting one. So getting it quoted for 10 drones will probably be fine. They're about the same cost as what it is right now, and they'll be professionally manufactured and assembled, so I won't have to be doing any of that work. Let's see. What else can I show you guys that I think you'd find interesting? So if you wanted a clean look at the bottom plate, this is really what it looks like. It's got the 6 holes in the bottom for the standoffs and everything. It's got big slots in the middle, and that's to support the connections going through the board, as well as just cut down a lot of weight to it. The Racer 3 plate was pretty much just a flat sheet and had a couple holes built in it like the Alien did, and had the motor holes in it. So and it's the same on either side. There's no like special engraving in it or anything. Might do an engraved copy or something like that. And I haven't gotten it quoted yet, but from what I remember on the Racer 3, it's about $80 for this carbon from the manufacturer that will actually do it. So I've talked to a couple of them, and some of them are like no, it's too close to the Racer, the TRL's product, we're not going to cut it. But a couple of them are like, yeah, we'll cut it. Camera mount, I'll bring that up. So the camera mount's a little bit cleaner than the Racer 3's camera mount. On the bottom of the Racer 3, you had a little indentation section on here, and it had little grooves on it. I think they did that to cut weight down. This is a TPU or TPE part, so that things can flex a little bit, and it adds some cushion to when you do a head-on collision. And it mounts to the PCB or the main board from everything on this front section. The servo will probably be placed here, and I don't think it'll be geared. I'm not sure yet how I'm going to work that in, but it might just be on an arm that connects to a custom plate that screws into the back of the camera, and then it tilts the camera along the screws here, and those will probably have to be Loctited in so that they don't rotate in the camera, they rotate on as a whole unit. Or I can put them on bearings, either or, but these are so small that bearings might not work. When I designed everything up for the, because of the angles that the ESC arms are at, that's not the right thing. That's the LED panel. LED panel, it's got this big capacitor on the front of it, and that'll help with things not getting burned out or anything like that. What I was going to show is where was it? It was this one. Nope. Did I delete it? I don't think I deleted it. Ah, there it is. Okay. So this was what I originally designed up for the ESCs. It's just one ESC that has the dimensions of a little long by the width of the arm. And once this was designed up, I just imported it into. I imported two versions of it into the actual 2-in-1 ESC. Rotated everything, renamed everything so that they were correct and the connections didn't cross. So like the connections from the BB2 chip and the maybe this is the BB2, I don't remember, the BB2 chip and the MOSFET driver, if they so they didn't cross to the other ESC, they were separated, and that worked out great. And then you have the, I don't really know if they're needed. They might be needed to program the ESC, but I'm not 100% sure. You have the 3.3 volt, the data, you have the ground signal, and you have the clock signal pad so that you can connect to it and configure it if needed. If you buy things from me, everything will be already flashed, tuned, and tested. Looking for anything else people want to see or ask me, or suggestions maybe. Sky FPV, I know you've been kind of active in the chat. Arrow Flyer, you've been active. And Pew Pew has been active. Good old Pew Pew. I know people are going to ask, like, because I showed it, but I know people are going to ask about this file here, Ninja Ripper. Ninja Ripper, if you don't know, is a program designed to rip models from games. So I have that in here because I used it to get a couple things that aren't shown. And then from there, I built everything up from scratch. So I used it as basically a reference tool, as well as using the simulator for a reference tool. So if you want to see what that actually outputs, we can go back all the way to the beginning and open this. So this is what was imported from Ninja Ripper. And you're like, well, what do you, yeah, this stuff is here. The actual outline is here, but it's kind of crude. If you actually convert this into a model you can use, it's very unusable. Everything sort of clips in itself, and you just basically have to redo it. And then the battery is still something that I have, just because I'm not planning on remaking their battery, so I don't need to redo it. Battery leads are there for reference. All of this is crammed together, and like it's not in anything useful. Like these are just photos. Like there's no model here until you actually get to, I think it's global. No, not global. Bodies maybe? Yeah, so bodies. So once you actually export all these bodies, they turn into every single face. Like these are all polygon, all triangles. Once you export them, it's just all faces. So it's hard to use them. If you try to stitch them together to try to get something useful out of them, they don't work. And you have like, this is the LED panel, and there's holes in it. There's nothing really on the inside. That's the camera. It's just a Runcam Swift. A Runcam Macro Swift. I can't remember exactly. So you have a GoPro there. If I can stay selected on it. Yeah, there. You have the motors. The motors are inside of each other. So you have one motor, and then I guess you can copy it, but no real point in that. Yeah. So that's what the original import looked like. And if you were to, you can do this yourself. It's a free program. That's what that'll look like. Okay, last call on anything else anybody wants to know about. If not, I'll just end the stream at 3:30, which is in 7 minutes. And I'll update you guys on the Facebook chat, and again on another stream coming soon. Probably another stream next week sometime. But definitely for the, stay tuned for the recording release of this video. And that'll go up on YouTube. And if you're curious, most of the components are sourced from China. That's just how I had to do it. The circuit boards are manufactured by a company called JLC PCB. I could have gone with PCB Way or PCB Cart. PCB Cart is the company that would actually assemble these for me. JLC PCB and PCB Way do assembly, but they're only one-sided assembly, I think. So PCB Cart is a double-sided. So things like the flight controller, the LED controller, and the underarm LEDs and the ESCs are all two-part components. Pretty much everything except for the power distribution board and the LED panels. See if I missed anything. Did I miss anything in the chat? Nope. Alright, well, I'm going to wind down the stream. Thank you guys for watching. If you have any more comments or questions, just feel free to message them in the Facebook chat or message me directly through Facebook, or my email is available from Facebook. So that's been the Racer 4 LA, the vlog number 1. I'll probably come out with a vlog number 2 next week, and hopefully everything will be completely modeled up. I'll even have the where the VTX and receivers will sit, and even I'll try to mock up a version for the DJI HD hub, and that'll go in probably where the GoPro is if there's not enough space anywhere else. And then I'll also be working on getting it so that there's an option available for you to add in your own components, like your ESCs, your flight controller, and everything else, and make a different version of the LEDs so that they're all they act as one channel per board, so each board will be one channel, so you can configure them via the Betaflight controller. And that'll be my goal for number 2, and hopefully I can achieve that. So thank you guys for watching, and I'll see you guys later.